Welcome, welcome, welcome. This is the Riveters CAD training course. Introduction, lesson 1, so part creation and an introduction to CAD. So, why do we need CAD? This is a prime example of not planning ahead. With CAD, you can plan ahead and get around issues similar to this, where we've got support poles going through windows. I've had experiences in robots where we ended up having interferences, and professionally unanticipated interferences in between two parts. Normally your problems don't occur within a part, they normally occur in the interaction in between two parts. So what does CAD help us with? Every year when the game comes out, there are certain constraints, and there's 3 major constraints, which are weight, the size of the robot, height, width, length, and the cost of the individual components. When we put these into CAD, we can generate a bill of materials, which is a list of all the components and how much they cost, and then we can figure out if we meet the $4,000 requirement. So how's CAD work? In CAD we make parts. We take those parts and put those in assemblies. The other thing we do with parts is we make drawings of those parts. Those drawings get printed and sent out to the shop, and we create the actual physical parts from those drawings. So what are the steps we go through to make a part? Well, the first thing we need to do is fire up Autodesk. So I'm going to turn on Autodesk right now, and I'm going to page down. So once Autodesk is up and running, we want to go into Vault, click on Vault, and then start the Vault server. Well, actually the client to the server. Once that's done, we need to switch back to Autodesk. Then the next step is we take the brand new part we just created. So we're going to create a part. We're going to come in and we're going to save that part. So say save as. This is my 3rd iteration of this this individual part, so I'm going to save it as DWG rear cross member. So the first thing we do when we're creating a part is we always start from a sketch, and sketches can be, when we're creating a sketch, there's different views. When you look at a part, you can look at it from side view, the front view, the top view, bottom, back, left. In this case, left. There's also projected views where you look on directly into a non-orthogonal face, which means it isn't a right view, a left view, top view, side view, front view. So what we do is we actually pick a plane to create the sketch on. So let's start a sketch. And since this part, I like to create the parts in the direction of the orientation they're going to be in the final assembly. Since the rear cross tube is going to be at the back of the robot, so if you look from the right end, you would be looking down the length of the tube. So I'm going to select on this plane. I'm going to hop back to the presentation to make sure that we're not too far out of sequence. So now, when you're creating, when you create sketches, it's a good idea to have them centered up on the origin. So I prefer to have the rectangle with a center point. So move over top the origin, which is dead center in between the 2 lines. Click left, left click, move up into the right, left click, and you'll now see that we created the square. And you'll see all the lines are green. As parts get constrained, which means the program understands the absolute position of the line, they'll turn from green to blue. So in this case, I'm going to touch on the line, left click on the line, move up, left click again, and I'm going to set this to 1 inch because we're making a 1 inch by 2 inch tube. And the right line I'm going to click on, move to the left, left click again, hit the number 2, and now we've created the section, or part of the section. Left click again on rectangle, come to the center, move up. Now you'll notice as I move it will jump onto the line. That means that that corner is constrained, but we can't make the right geometry. So it's a good idea when you're creating this to make sure that the point doesn't auto constrain to another line. So I'm going to left click, and now I'm going to select dimension, and the wall thickness on the Vex tube is 1/10 of an inch. We use a fair amount of Vex tube in our robots, and I'm also going to do the same thing on the bottom. Now why can I get by with only one dimension at the bottom? Why don't I need a dimension at the top? Because we use the center rectangle, it makes it symmetric about the origin. So the size, once you put a dimension on one side, automatically the other side goes to 1/10 of an inch. And now we finish the sketch. Next, we're going to, let me make sure we're synced up. So going through, creating the rectangle, putting it in, dimensioning it, and we finish the sketch. Now we're going to extrude this section. So we're going to come in and click on extrude, touch the center section of the profile of the part that we want to extrude out. I like to make my part symmetrical about the origin and symmetrical about a face. So the reason is it makes it assembly much easier, and you'll see this later. By clicking this button right here which says symmetric, and the overall length of the part is 30. Click OK. Now you can see the tube has been created, but it's very, very hard to see at this point. If you take your middle mouse button and you roll out, you'll see the part moves. And then I pushed on the middle mouse button down, and you can pan around. And then if you hit the shift key, you can actually spin. Now let's say your part is way off the screen and you can't see it. So you can't even identify the part. If you come over the top of the cube, you'll see there's a little home. If you click on home, it brings that part and auto scales it so you can see it. Alright, I want to make sure that I'm aligned with the training pamphlet. So the Vex tube actually has holes across the top. The hole starts a 1/2 inch in from each end, or from one end of the manufactured tube, and the holes are a 1 inch spacing. So we're going to go through and create those holes on the top. So I clicked on the top of the tube, I hit 2D sketch, and now I'm going to take and create a circle. I'm going to purposely create it outside the part right now. So there's a circle, and I want to make sure, last time I did this I didn't align to. So the first thing they did was they went through, escapes your friend. So see how I had a circle and I started one and it started to generate the geometry. If you hit escape, what that does is it backs you out of that command. So now the first thing that we're going to do is we're going to take and align the center of this hole to the center of the end of the tube. Next, we're going to dimension the hole. Come in, click on dimension, click on the edge of the hole, I move up into the right, and I know that this hole in the Vex tube is 164 thousandths, so 0.164. And then now we need to create a dimension for the end. So see how I move around? And you'll see the dot in the center clicks, and then I touch on the yellow line, bring it up, put it in a half, And now zooming and rolling the zoom in to see we've actually generated the geometry, and we're going to finish the sketch. So now we're going to take, we want to actually take this and create a cut. So we're going to say extrude. First, since the section was selected, the profile is the section that we're going to actually go through and create. In this case, it thinks that we want to make like a toothpick on top of, a round cylinder on top of the square tube. We don't want to do that. We're going to come over here where it says cut. We're going to touch on cut. Now, it's a good idea if you truly want to have your hole go 1 inch in, you leave your distance at 1, this in case is 30 inches. But in principle, you should always click on all, because that's your intention. You're intending to go through both, going through both holes. You don't need to set this necessarily symmetric. You know that you're going to go down. That way, for instance, if you change this tube to a 1x3, which they actually do make 1x3 tube, if you were to do that, the hole would go through both sides. And we're going to say OK. So now we've created that hole. Now the next thing to do is we want to take these holes and push them down the whole length of the tube. So we could create a sketch and put 30 holes on it, and that'd take a fair amount of time. It's a lot easier to go through and say, create a rectangular pattern. First thing you want to do is here's your feature. We want to touch on the hole and see how it highlights in blue. And then we want to set the direction that we want to move. So I'm going to touch the edge of this tube. See how the green arrow moves to the left? And it shows the holes. So this is the number of holes you're going to have, and here's the spacing of the holes. This is not going the right direction right now. In fact, right here it says flip the direction. Now you'll see the hole move to the other side, and we want a total of 30 holes. So gone through, type in 30, and you type OK, zoom back out, and you'll see that the holes run down the whole length of the part. Alright, let me make sure I'm aligned here to the presentation. Now what we're going to do, what is the material of this part right now? Well, let's set the generic. If you hit the down arrow next to it, and you come up and click on aluminum 6061, is this the normal aluminum that we're using within the robot. So now what it's done is actually set this part. So why is that important? That's part of that weight constraint we talked about earlier. So right click on the part in the model tree, go to eye properties. In the upper right corner it says physical. Click on physical, and that's the actual physical properties. And if you say update, it actually shows you the volume in cubic inches, but it also shows you what the actual mass of the part is. So this cross tube actually weighs 1.626 pounds. So we went through and we actually measured the weight of the part. So now we need to put holes. Since this is mounting into a chassis, there's some mounting holes that will go to the upper braces in the corners. So we need to go through. When you're creating a sketch, you want to pick the surface you want to sketch on, and then hit 2D sketch. You could do the other way around. You can hit 2D sketch and then hit the face. And now we're going to put 4 holes. Now these holes, are aligned to each other. See, I clicked again, so I'm going to hit escape. And probably ought to put that in the presentation, the PowerPoint. So I'm going to take and align, all 4 of these holes form a box. So the left hole and the right hole centers are going to align. Same thing with the bottom here. I'm going to click on those, and it's going to move those holes into the same alignment. And now I'm going to form the left side of the box. And click the upper left, go to the lower left, and see how that jumped over. And now I'm going to do the same thing. And when I click on this one, the bottom one's going to jump. Now these are all forming a box. Next thing to do, I believe is to dimension the hole, which it is. So click dimension, click the hole, move up into to the right, click again, and the hole that we're using is for a 1024 screw to attach this tube to the corner brace. So we're going to type in 191. Now you'll see everything jumped based on that diameter. I believe the next thing we do is we use the constraint. This constraint right here, if I hover over it, it says equals. What it will do is when I touch the upper left hole, once again I started to create a dimension, so I'm going to escape out of that dimension, and now I'm going to hit constraint equals. I want to say I want to make this hole right here equal to the first hole, this hole equal in diameter to the hole here, this hole down here equal to the diameter of the hole in the upper left. So now if we change the dimension on this hole, I'm going to hit escape and get out of it. But let's say I come in here and I change this dimension to 1, right? You'll notice that all 4 holes changed size simultaneously. But I'm going to set this back to 191. Now we need to dimension these holes to the part. So first thing is we're going to dimension from the center of the hole to the end of the tube. We're going to set that to 1 5/8, 1.625, and now you'll see the holes jump across. And then I'm going to take the center of this lower right hand hole and I'm going to reference it to the bottom, and it should be up 3/8 of an inch, 0.375. Now all we have to do, since that box constraints, we put those box constraints in, the other 2 lines moved, or the upper right hole and the lower left hand hole moved. Now we need to, I'm going to hit escape, and I'm going to grab the center of this hole, I'm going to drag it into the middle of the part, and I need to put 2 more dimensions on here. I need a dimension from the end to the center of the hole. Once again, that's 1 5/8, 1.65, and then I'm going to touch to the center of the hole and go to the top of the tube, and 0.375. So the sketch is complete. We have 4 holes on the part. We're going to come in here and finish the sketch. Let's go in and check and see how we're doing against the actual presentation. Alright, so it's a good idea to periodically save, and then the step after that is to the extrude. Missed the extrude. So hit extrude, and now this is a little bit tricky. We want to come in and touch in the centers of each of these holes, so you have to zoom in, and you'll see once again we're creating those little cylinders coming off the face, but we really want to cut to go all the way through. Set that to all and say OK. This completes the part, so we need to save. Hit the save button up top and come into Vault, and then say check in. If you've completed all these steps, it should show like this on the screen. If you want to do a check and make sure that you've got all the features, it's a pretty good thing if you check. You'll see that we decreased by, we went from 1.626 to 1.624. Those little holes took a little bit of weight away, and the program picked that up. And congratulations, you've completed your first part.